Okay. Hi, Mara. How are you today?
How are you, Scott? How are you?
Okay, fine. I'm coming to you from an undisclosed location. And today we're going to talk about the figure three reveal. So it's been a little over 24 hours since figure revealed the figure three that we know. It's we've been waiting for it for a little bit, and I think it's given us enough time to maybe give a much better take on what we were able to do when it first came out, because we've received a little bit more information, had a chance to digest it a little bit more, and could probably answer some of the questions. And actually, you put out a post today saying, "What are some of the questions that the viewers have?" And we'll try to address them as best we can. So, what were your first impressions?
Well, I think the first thing is aesthetically. I think it looks very sleek, and what I really like it in there, I think, why they were the tactile sensing. I think that was interesting, and also the touch of having the
Yes.
softness in the design to avoid bench point and having double layer.
Yes.
I think foam, and I think that was very interesting to see they considered in the new iteration to have this softness in the design for
Yes.
homes. I think that was interesting. Yeah.
Yeah, it is. So the aesthetic is absolutely stunning. They put a lot of effort into doing that to make it look far more like the robot we all envisioned. It's very sleek, and you don't realize how sleek it is until you actually compare it to Figure Two. So when you look at Figure Two looks really brawny. And the description that Brett sort of had is of the three different versions is the very first one looked like a knight in armor. The second one was built a bit more like a quarterback. Oh, sorry, the second one was built more like a linebacker, whereas Figure Three is built a little bit more like a quarterback, a little bit sleeker, a little bit more nimble. And the first thing you notice is that the shoulders are so human-like. Everyone else's shoulders look mechanical. You can see how they're done, but it's just an unbelievable aesthetic there that the shoulders are remarkable. Part of it is because of the padding that's around there. And the rest of everything, they've been able to optimize quite a bit to reduce weight in many places. And as a result, the actuators are able to be a little bit smaller. But I think even though they're a little bit smaller, they may have a little bit more torque than the previous generation, just because the actuators have improved quite a bit. So overall, it's very human scale, without a doubt. It's very soft. It's not just a fabric covering. There is a little bit of padding underneath it, and more padding in places where it's really sort of needed to provide protection. So it will be a lot softer. But of course, despite that, it's still probably not quite at the safety level that everyone would like it to be. And Brett is actually on the record in the interview he did with Time that there's still a long ways to go before you would consider these bots to be sort of safety certified. Yet, despite that, they are designing safety in from the ground up. Really thinking of what are all the subsystems have to have, because we want to make sure they're very safe. And I would say one of those areas that they spent a lot of area in the safety is in the battery pack. You may wonder, well, why is that important? And part of it is that you want to make sure that the battery pack does not burst into flames. That if the bot falls or something else, it doesn't overheat. If something happens to the cell, that you're able to contain that and to make sure that no flames are external. So if it's going to be in the home environment, one of the first things you have to do is make sure your battery packs are safety. And they actually help establish some of the safety protocols for these packs with UL. And it's very rigorous. I'm surprised. It's almost like EV level kind of safety protection. And part of the safety comes into their philosophy of having a structural battery pack. And we've probably heard that before. Uh, Tesla uses that now in some of their cars. I think, the latest generation cars have gone more this idea of a structural battery pack. And by making the batteries part of your structure, it means you can lighten other parts of your structure. And when it comes to a bot, that's one of the first things you want to do is what can you do to lighten it? The problem with a structural battery pack is that because it's structural, you swapping battery swaps are out. So you either have to believe in the philosophy of being able to do a swappable battery pack or a structural battery pack, which will give you a lot more strength, will not take up so much space claim, allow you to have maybe a slightly bigger battery pack as a result. So you'll have longer runtime, but the problem is you're going to need to charge. And it seems that Figure has addressed that issue in what is now a novel way for humanoid bots. And do you know what that is?
The inductive charging.
Yes. Yes. So they have inductive charging in the feet. And this is a very common comment that we've seen for years. Just like, why don't they just use inductive charging and either do it in the feet or potentially in the back? It's like close to the backpack. So rather than having to plug into the wall, why not just back up to the wall and charge? And I think a lot of the reasons that you wouldn't want to do that is like, well, since you have to go to the wall to back up and charge, just what's the difference between just plugging in? So if you're going to do the induction, you're going to want to do it someplace that's very convenient and allows you to charge very easily and maybe charge on the fly. And so it does sort of make sense to do it down on the feet. The pushback on that, of course, is that you're adding a lot of distal mass, so more mass towards the extremities. And as a result of that, it's going to be harder on your overall drives because you're trying to do as much as you can to reduce the mass and now suddenly you're kind of putting in there. And then, you've got to make sure you've got wiring now. It goes like all the way down to the soles of your feet, whereas before it kind of stopped, at the ankle. We had a little bit going in there for sensors, but you didn't necessarily, have to have thicker cabling to be able to handle the charge. Um, so they have induction plates and they actually have them on both feet. So it's not on one side, which means you balance the mass. You don't have one foot that's heavier than the other. You have both of them. And the result is the overall charging speed is 2 kilowatts. And to put that into a little bit of perspective, um, your hair dryer maxes out at 1,500 watts, not 2,000 watts. Um, in the U.S., that's the maximum you can do it at 100 volts, 15 amps. You can get a special circuit that might be 20 amps that would get you up to there. So typically, if this is going to be in a factory, you would probably have 220 already there and would be able to do it. So that's more than enough. The big question is about, inductive charging. Isn't that very lossy? And it turns out it's not. You're talking about 95% efficiencies. And actually, a lot of that inefficiency is more on the wall side than the bot side. So the losses tend to be more there. And inductive charging has improved quite a bit. In fact, a lot of EVs are considering that. I believe the Cyber Cab is also going to be using inductive charging. So it is, and if and if you're really worried about energy losses, charging an EV, I would be more concerned about the potential losses there than I would with a bot, where you're talking about a pack that's like 1/30th the size of what you would typically see in an EV. So they made that decision, and you'll see that there is a charging stand. And then on the pelvis, there are actually 2 hooks on the pelvis that help support it.
Yeah.
So they decided to do that rather than kind of this back, wall mounted on the back where it's much higher up on the torso. And so it's a much lower point and it's much easier to kind of cantilever it right on there to hold in that position. Now, behind there, so the normal way of charging will be wireless. And there's a close up that we sort of see in the teaser video, where you might even see it in this one every now and then, where the torso swings around. And we'll make sure in the magic of the editing room, we get that kind of clip in there. You can see underneath, and you will see those 2 attachment points. And you also see right in the back, right in the small of the back, there's a small little opening. And that is a data access port that also has charging. So if you don't want to use the wireless inductive charging, that's still another way. You might get slightly higher rates, but it's still going to give you the charge anywhere from a half an hour to 50 minutes to be able to get up to where you need. So I'm not quite sure the size of the battery pack. We can guess at the size. We know that figure 2 was 2.3 kilowatt hours. This battery pack, I remember counting the number of batteries. I don't have the number right in my head, but we saw bot Q. And if you count the number of batteries in there, it's probably slightly less, so they were able to lighten the load of the bot a little bit more. But as you lighten the load, also the power requirements go down a little bit, so it has like the same runtime. So I think it's on the order of of 2 kilowatt hours as opposed to 2.3, somewhere around there based on it. But the thing is, if in the interim, battery technology has improved since the last time I did that calculation. And so it could be that they're still somewhere around the 2.3. And so that gives you an idea. If it's 2 kilowatt hours, then that means it takes an hour at 2 kilowatts to be able to charge theoretically from 0 to 100%. But you can't do that because the charge curve is a little bit different at the beginning when you're at a very low state of charge and at your very high rate. So, yeah, so and it might be that they might be giving it that much charge all the way through because typically these packs could take more in the sweet spot. It's just not delivering it. So, yeah, that's how the charging is working through inductive. Well, what are your thoughts about inductive charging?
I think it was very interesting, their approach, and I'm not sure if it's the motivation to go for that. I would think, is it just a space, take advantage of the feet? What is the rationale to put
Well,
the
I think
deductive?
everything comes down to use case, and again, there's several different philosophies out there. One is just plug-in charging. Um, the other is battery swaps, and the other is inductive, and they all have their pros and cons. And it's going to depend on the use case and a bit of the philosophy that everyone wants. So the thing with swappable battery packs, they tend to be smaller, and just so that they can be swappable. And the fact that the swappable takes up precious space in the torso. You need still a sealed battery pack, you need connectors, and then the torso has to receive it. But because the torso doesn't have the advantage of a structural battery pack, you might have to make it a little bit stronger than normal. If you have a swappable battery pack and you want to self swap, then you need to still have some onboard batteries, which in the case of one bot that we've seen actually has two swappable battery packs because it still needs one to keep it going so it can do the swapping. So you kind of see that be as an issue. And you still need to get over to wherever the swap area is to do that. Whereas if you have a structural battery pack and you can charge your place because you're not moving, potentially you plug in. But anyone who's used a VR headset, which is cabled versus wireless, we know the advantages of being wireless because we don't constantly have the cable wrap around and we don't trip over it and everything else. But of course, the advantages of having something that's cabled is that you can probably deliver a lot more current. And it's, and in theory, it's usually the best efficiency. But it turns out that having wireless charging, inductive charging, is extremely efficient now. I mean, I think that's 3 years ago, people would have said, no, you don't do it. But now it's like, they figured out how to get the efficiency in the coils and everything up high enough that you could do that. So that means you could charge in place as well. So if you're, obviously, if you're just standing, you might think, why do I need even the legs if I'm just standing? But a lot of times these operations that's happening at a table might seem like a stationary one, but you're still moving around a little bit. You might have to take a step here and there. Or you may have an operation that requires several steps, but then you come to a location and you're stationary for 20, 30 seconds. And in that time, you could get enough charge maybe to keep you going through whatever that entire cycle time is. Or if even if you're not getting the charge, you could prevent discharge. And sometimes just, preventing discharge is just as good as charging in many ways. So it would extend the runtime overall. So yes, that means you would have to put special inductive mats down to be able to do this. But if you go into a lot of factories, there's already a lot of mats in place already, either for operators, so they're more comfortable when they're standing, or they actually have mats that have sensors and other things in there because that's part of their safety system to know if a person is standing here, we're aware that that person is there. So it's not necessarily as intrusive as you think, and it's not like the whole floor has to be done that way. You would just do these certain areas. But the thing is, it gives you that option. That's one of the things. So I know there will be some that think this is a great idea. I think that's not. Probably the biggest criticism of inductive charging is the mass it puts on the feet. It makes everything heavier. And now you're putting up both. Mhm.
What do you think about the future of the charging here? We have solar battery and the inductive charging. So do you think this is something maybe beyond these two options down the road?
It's hard to say. The reception from a lot of people, so it's, other some roboticists like it and some don't. Because everyone has gone down the same design path. They're looking at all these things and making the same decisions, and there are reasons why some people decided to go swappable and some people not. Some people to plug in stationary chargers and some not. Everyone kinda looked at it, and they made a decision for a variety of reasons that it didn't fit their use case or the technology was not ready for them. And so, they're all coming from a good place making this decision and, like, whether you should do that or not. Um, because of the pros and cons. That having been said, it's good that someone has decided to go out and try this because we're gonna get data. So rather than having this philosophical argument, a lot of times the best thing is like, well, at least someone's trying it, and then we'll see whether it's something that they end up abandoning in the next version or the version after that, or if it's something everyone else starts adopting because they realize it. Now, when it comes to EV charging, um, a lot of people have been talking about it, but most of it has been it's a bad idea to now it's more kind of consensus. Maybe it's not a bad idea. And also, communities that are thinking of putting inductive charging into the pavement because it'd be a lot easier when people are parking that they don't have to plug in and having these cables and everything else and reduces vandalism. And that a lot of cars are going to do that. And again, like I say, the cyber cab is using inductive charging because the state is up to the point that the efficiencies are good enough that it doesn't make sense to do direct charging. So I think there's a kind of a little bit of a shift. The roboticists again probably just don't like the idea of the additional mass. But I did have the opportunity to visit Figure after hours yesterday and held the foot in my hand. It felt like holding um,
What's the impression?
the impression was
Tell me, Scotland.
it felt like I was holding, a pair of Air Jordans in my hand, it's just like because it looked like a basketball sneaker, and it didn't feel heavy to me. It was kinda remarkable. I was expecting it was gonna be, "Ooh," and I'm not a guy who goes to the gym all the time, so when something weighs a few pounds, I notice it more easily than the guys that are, like, really buff and strong, and to me, it just, like, it didn't come across as like, "Oh my god, you're thinking of putting that on your feet?" I've held steel-toed boots before, and they feel heavy to me, and in this remarkably did not. It felt extremely light, and, frankly, it just didn't feel like it would have been any heavier than maybe most of the robotic feet that you see out there anyway. So, that was something that kind of impressed me and maybe is the reason why I said, "Yeah, we're gonna put it on both sides." Just it's light enough, that we can do it, and I don't know, maybe that's part of the trick, but, I would think that maybe you're able to kind of reduce it by the fact that you're spreading it out over a big area. There's probably something going on. And the other thing about the foot that we've noticed is that it has a toe box.
Yes, the articulated tool. It's
Yes.
similar to Tesla. It's the same design in the articulation. Okay, tell me about that.
Um, I think I mean, a toe box is a toe box. So the idea is that the front like third or quarter of your foot is able to articulate. And in that articulation, you need to use a um, you need to have something which acts as like as a spring mechanism to return it back to its neutral state. So normally your foot's going to be flat, and then as you push off, the front part of that section is going to articulate, and then as you do the full toe off, it's then going to push back. So you need an energy capture device in there for being able to do it. And there's a variety of ways of doing it. Torsion springs is certainly one way, which is I believe that's how Tesla does theirs. Um, the impression, and I think the one difference I would say that actually surprised me about the Tesla toe box is the joint is, like, up so high that when Tesla's flexes, like, this big opening happens in the bottom of the foot. So it's like you're opening up this access point that if you go outside, you just know a rock is gonna get caught in there or a pebble. So I was really surprised it wasn't more flexible that kind of prevented that it was segmented. And you don't see them in figure three, that along the bottom of the sole, you don't have that. However, it has been sort of commented that you'll notice there's a hollow through passage on the foot. So when we look at the design, you'll notice, well, wait a minute, there's this hollow space that goes through the foot. And that seems, rather interesting. And that's a potential source of debris or other stuff getting caught in there if you go outside in the house, unless you have like a really cluttered house. It's not like, rocks and sticks and mulch and other stuff would get caught in there, or start collecting. So the question is, um, why is that part of the design of the foot?
Mhm.
So
The articulation.
no,
No.
nope, nope, that's not part of for articulation. What's the other property of the foot?
Yeah, I think balancing the whole robot, I think.
Well, no, this particular foot. What else is built in to this foot?
Ah, we got the induction and articulation.
Inductive charging, yeah, yeah. And, even though you expect the losses to be low, it's still gonna produce a little bit of heat. And so, part of that is to help cooling. But, if necessary, it's easy enough to cover up because that's probably the next thing that we can go to talk about figure three, and that is the coverings that they have on there. So not only does it have this kind of built-in covering that makes it all very soft, they also have what looks to be a line of clothing to go along with figure three, or different kind of uniforms to be able to put on there. And the idea is, part of it is for identification purposes of maybe what different fleets of bots are, or for corporate signaling, or, in the case of, a maitre d' at a hotel or a restaurant, that you'd want to have something that's a little bit stylish. But also the idea is that the garment, or let's say the covering they have in there, will offer some protection. It's not like it's necessarily waterproof or water resistant. And if you want your bot to go outside, you should think, well, what do humans do? Well, humans wear a rain jacket. So if you're going to go out in the rain, then just go ahead and don something like that. If you're going to go outside, then put foot covering on that's appropriate for going outdoors. Because when the bot comes back in, it's going to track that debris in the house, unless you have some sort of special cleaning stations, like we have like boot cleaning stations or something like that, or the bot knows how to clean the foot itself, or it's as simple as that you get a very a cover you just kind of put over it, that you would, your Macintoshes or whatever. I think that's like, no, that I think that was what they used to call the old rain jackets in Victorian England. But you can also have some very light foot coverings that would be able to do something like that in the situations that are appropriate. So, yeah, I mean, we kind of dwelled a lot on the feet. There's a lot of other parts of it. Now, what questions did we see in the comments regarding the covering? Just regarding the
I
cover.
think there's a regarding the cover. I think there's a lot of question about the garment. It was really interesting. Let me go quickly because I think there's a lot of question. I think about um. Let me. I think yeah. It's close to the right fabric skin. It looks like upper body is removable, but what about legs and forearm? If it rains, how we can have it removed? Also exposed to fabric.
Yes.
Hair is all plastic. Yeah.
Yes, yes, yes. So it's a nice woven fabric, with cushioning where it needs to be in other areas to kind of bolster it, and give that wonderful sculptured look, and everything else that they do to make sure that when it articulated, that the fabric folded nicely, and that it doesn't pucker or do any other odd things. Um, it's very easy to remove. So when we look at the video, we can see that there's a zipper in the back, and yes, at the very, very top of the zipper, you'll see the small on-off button. So there's like a little symbol there that looks like a start-stop button. And I can confirm that that is exactly what it is because I was able to press it and turn figure three on. So you press that
So
button.
where is exactly? Is
So on the back,
mhm.
on the very back of the video of it, you'll see that there's a zipper that goes down the back, and on the very top of the zipper, There is there's also, you'll see an area where there appears to be ventilation, and then there's also a small button there, and that is the start stop button. And then there's the ventilation on the top, and there's also vents underneath. That's what allows you to take the torso section off. And you'll see it kind of goes right up to the neckline. So that part comes off and it's really easy. And then you have the neckline part, and that's something that just snaps off. So it's a snap fit. It's basically very similar to the fabric snap-ons that you'd see in a lot of Bluetooth speakers. That it's very easy removable. So you can remove all of that fabric and replace it within 20 minutes. So you can go through, peel everything off, and put your next set on there if you want, and then do whatever cleaning. Now, I kind of joked with them. I said, I don't see any of the uh, tags on there that talks about how to care. So what are the care instructions for this? I don't know if it needs to be dry cleaned or not, but, yeah, that would be one way. If for some reason it gets damaged or wet or dirty, it's fairly easy to remove, put on new skins, clean those skins and put them on. So top to bottom, you could replace everything in under 20 minutes. See the very top there. So that part comes off, and then what you end up having is kind of, the upper neckline part. That peels off very easy, and then and right down onto the forearms, the rest of the body. So all that can be taken off, say in reasonable time, pop back in. You obviously there could be different color skins here depending upon what kind of branding different people want to be able to do. And then there was that other line that goes on top of it. Now the important thing is on the back, we can see where the ventilation is in the back, and we can see underneath that how the air gets drawn up into the torso and then it gets expelled around there. Now the other windbreakers that we saw in uniforms that you could put on, um, they also accommodate that. So they don't cover that up. They go around there and they also make sure to have venting on there. Um, just like you would in normal sort of jogging clothes or anything else. It's nice to have some air vents back there. Probably one of the biggest questions everyone has is about that product line that they came up with. Um, they look great. And
So it is a product itself, Scott. This clothing, because I just want to ask you, some people say it's a fashion, is it branding? What exactly
well, the
happening?
idea is that, there's you should be able to skin these things and skin them very easily. And some of them will be appropriate for the kind of function that they're doing. So again, if they're going to be going outside, you may want to give them some sort of covering against rain or anything else. Again, just being able to identify what their purpose is, whether it was a delivery bot or whether it's a bot that's working on the line. And again, corporate actions, because you could imagine you might have a variety of these bots intermingling in certain areas. You want to know whose bots is who. you know, is it, working for company X, Y, or Z. So that's one thing. And of course, it looks so nice. And this was actually done by the designers. It's amazing that they have uh, so much creativity when it comes to clothing like that. Um, I think they're considering putting it on their swag shop. Just considering, whereas I think everyone is just more or less like, "Here, take my money. Take my money. I don't care how much those things it cost. They look great. I want one yesterday." So, hopefully it's not gonna be, "Yeah, the problem is you gotta be the size of F3," because if they do have the line, then they're gonna have to say, "Oh, we're gonna have to have small, medium, large. We're gonna have to," it's like all the incumbent headaches that kinda come along with that. So then speaking of size, there was one question from many people, but I think, Phil Truby, he also wanted to know a little bit about the specs. And all you have to do, is like, many of these answers that I'm getting are publicly available, and all you have to do is go to the Figure website. So if you go to figure.ai, you will see a lot more about it. And if you click on Figure 3, it gives you a spec right away. Right. Now, I think the specs are being updated because I remember looking at it yesterday, and it may have been that they put things up kinda quickly, and there was a couple that I think changed since yesterday, and that is yesterday, I thought for sure it was 5'6", but it seems to have grown 2 inches overnight. So, it's now 5 foot 6, I believe, was the Figure 2 spec. So, it's 5'8", and it seems like it was about that height to me. So I was kind of wondering about the seeing that it was 5'6", so it does legitimately see like it's 5'8". The payload capacity, and that's what Phil was asking, is that it's able to carry 20 kilograms. And yesterday, I think it said 60 kilograms because I remember before it had been 70 kilograms for figure two. So it's like but it's 61. So they listed at 61. And usually when you see a number like 60 or 70, you're like, the engineers are probably rounding off. Or when you see 61, it usually means it's 61. It's, so that no one just goes ahead and puts a number on there just because they think it sounds good. That's probably because of what it is. So it's at 61. And the walking speed is 1.2 meters per second, which is right at the speed that you want for walking around the house and on the factory floor. It's not running speed. It's not super fast, but the real question is, do we want the bots going much faster than that? It's not a limited capability. It's just that that's kind of the speed that it's at right now, and it's more of like the operational speed. Uh, they could make it go faster if they really really wanted to. What that top speed is, I don't know, but the specs that we see there, we get kind of an idea.
The runtime is 5 hours, is
Yes.
right?
Yes.
Runtime.
Yes. Yeah, it's always been a 5, and that makes sense based on the size of the battery pack and everything else. So that's about, and of course, there's gonna be different modes of operation. If you're working it really hard, you're gonna see it's gonna be less than that, and if it's just doing light duty work, you'll probably see more than that.
Mhm. So, I think one of the also interesting things, yeah, what I think the sensing, but maybe before going to sensing, maybe the softer question, I think, because I've also read it also in on X, and I think there's a lot of, yeah, I think hate for figure, and people call it fake. I'm not sure what you think of this division and of the this new demo. So I'm not sure if you're able to
Yeah,
talk
I
about
I
that.
I I think the best thing is to just kind of address the more upbeat and positive comments because it's for real. It's there. I've seen it. I've touched the bot. Um, and I've been able to interact with it to get an idea what's going. I know a lot about the team that's working there. So it's legit what's going on. So and there's some legitimate criticisms because in all these videos, they never show us as much as we wish they would show us. And a lot of it because they're trying to get, certain mind share and good production quality out of it. Um, obviously, I would like to see more examples of hand dexterity, of clearly picking up objects in a certain way that may be more difficult because we know a lot of these bots can grab and hold it. And I've had the same criticism with Tesla in 1X and Apollo and all those that on some of these things. I just wish they'd show me a bit because I know you guys can hold a beer bottle, but I want to see what it's like to pick it up. What's it like to pick up a keypad off the table. But I think we've seen some pretty good examples in there of where Figure was doing some of the housekeeping, and it was able to pick up some challenging objects by doing some tricks within the limitations of what it has. And I think there's kind of two limitations going on here. One is the hand is not exactly a human hand. It can't do everything a human hand can do. So with those limitations, you have to do it a bit different. And people learn to do that who have arthritis or an injury or something like that. They find, there's another way I can still accomplish this task. Maybe it's not as efficient as someone who's got a fully enabled hand, but I can still do that. And the other thing is that when you are doing teleoperation, it is so hard. Even if the robot has the capabilities, it's hard to unlock the capabilities because teleoperation is just difficult. And then they have to do something and when we talk about teleoperation, that's the training side. So everything here was autonomous. But it's been trained through the teleoperation that when you want to pick up the dishes, you use kind of two hands where one hand kind of pushes on the dish to pop up the other side. So it's very easy for the hand to get underneath and it's very easy to grab that. Some other tricks of getting, I think one of the plates off the table is it kind of almost slid the plate off the table as opposed to trying to pick it up. The laptop was able to pick up on a soft couch, and if it's on something soft, it's a little bit easier to be able to get underneath to get that leverage that you need. Whereas a lot of times these things are much harder to do on harder surfaces, and we're all aware of that these bots won't be able to do everything. And I think even in the time interview, Brett talked about it's like we're getting a lot done. It's not perfect that you will we'll see these operations, and the bot's working perfectly, and suddenly it has a problem, and suddenly it drops something, and it's like, so what's the improvement? And the question isn't that the bots are making mistakes; is that they're making less mistakes over time. And if those mistakes, and the other thing that's important is that when they do an error or a mistake, how well do they recover? So we might say, oh, it tried to grab something and it did an air grasp. It missed the object completely. Well, did it realize it did that and went back and picked it up again? Okay, so we would say that was a mistake, but there was a good recovery mode. But sometimes the recovery might be there is no recovery because the mistake is catastrophic. Like it went to pick up the package, it missed the package, or it picked it up and it dropped it. And it dropped it on the ground. There's not one where it's on the ground, it's lost it. Okay, that's like a full blown mistake. But in many cases, if it just was like a mispick and it gets us a second time, we do it all the time. We think we get something and we miss it and recover. So once it starts to get to more or less human level uh, error rates, then it's extremely useful. And even if it's not, uh, you know, uh, when when our kids are growing up, they're very incapable of doing a lot of things. At least they're not able to do it at the level of adults. But we do teach them to like start cleaning the dishes and cleaning up their rooms and stuff like that. Maybe they're a little bit slower than us and they're doing quite as good a job as us. But you know what? They're doing it. And maybe it is good enough, you know? It's like the dishes made it in the dishwasher. Maybe they didn't rinse them quite as well as we want, but they came out of the dishwasher clean. So I guess that's good enough. And maybe there's a more efficient nesting strategy that as adults love doing. Um, but they're going to get better, so they will become efficient over time. So and it, it- and they're all at that level. It's like there's no one that's in this leadership position that they've got it nailed yet. They still all have a ways to go. And this is what it's going to be: is that the early adopters are going to have to understand these bots are not going to do everything perfectly at first, and you just have to decide what's the pain tolerance you're willing to put up with in order to get them to that state. Uh,
Let's speak uh,
mhm.
about the hand because I think that you what the balm camera, the camera in the balms. I think that
Yes,
was interesting.
yes, yes.
Before going to that, I think also I think lots of questions really, but I think one of them about the pricing. Do you have an idea how much that will be cost?
No, no, that I don't know, but I believe the cost will be significantly less because they're developing a production line for these. So figure one was extremely expensive. Um, Not sure what it is. A lot of people guess probably in the order of $1 million because it's, you know, yeah, very, very bespoke. They had absolutely nothing, so it would have been very expensive. Um, but then figure two was designed to be a little bit easier to build, but they never intended figure two to have quantities in the thousands. It was figure one was to get some proof of concept and something in the AI team's hand that they could start working on their models and seeing what was needed. Figure two comes out, and it's a much more capable bot, one that they can produce bigger numbers of, but still probably in the order of $100,000 to produce. So they factor a 10 improvement, but still a lot. And the reason is they didn't have any hard tooling. So I sort of joke that Figure's biggest product for the probably the first and second year of operation was aluminum chips, because these CNC machines that would just be running nonstop, and you would put in this big aluminum billet, and it would just machine away and machine away, and 95% of it is turned into chips, and then out of it suddenly pops a torso for figure two. And so those are very slow production techniques to do that because they never wanted to do these in volume. They just wanted to get something quick enough while they start designing the one that's meant for scale. So you start going more into your design for manufacturing. So making sure, okay, what's a more efficient way of making this torso? Well, can we stamp these things out? Well, if you look at the bot Q line, you for the battery line, you'll see that they are stamping out the torso. So all the sheet metal is in there, and they're able to put those things out, and a matter of seconds that they're popping out what they need for the structural elements of the battery pack. And then then the batteries have to go in and everything else, and that takes a little bit longer. There's a lot of steps that are involved in there. We'll talk about it a little bit. That we saw one image of figure three working the bot cube battery line, uh, doing one of the operations there at the image. We can come back a little bit later because I don't want to get sidetracked like I usually do here. So the the cost is significantly less. Brett has mentioned it. It's also one of those things that's probably almost, a factor of 10 cheaper. So, they could be getting it down in the tens of thousands of dollars now, whereas before, maybe it was hundreds of thousands of dollars. So I don't know if it's exactly 100, maybe it was like a quarter million or something like that. So if it's 10 times better, then we're looking at maybe they already have it down at that $25,000 level, which I mean, this is speculation. I don't know for sure. I have not heard any number say what. Yeah.
I see the comparison, I think, most of the time in this discussion about unitary.
Mhm,
It's already in Walmart, you already saw that. So
mhm.
do you think it's a fair comparison to compare Figure with Unitary because Unitary is really preparing for IBO, and do you think it's fair comparison?
They're very different. First, Unitree doesn't come with any. You can buy a Unitree bot for 16. That's the I think the G1. But then the G2 educational version is like $69,000. And that's the one that has actually hands or, has a wrist on it, has a few other things in their developer kit. So yeah, if they wanted to, they could come up with a stripped down bot too. Oh, we won't give you the hands, and we'll give you like a battery pack, and we won't give you any autonomous capability, and we'll make sure it's only about 4 feet tall. So it's night and day when you look at the two. So one is adult size, the other one is hobbit size. That's a big difference. One actually has functioning hands, one doesn't. So and again, Unitree has a bot that's also pretty expensive. And I'm not talking about the 5'9". I'm talking about the little Unitree. There's a version that go out there on the Unitree website right now, and you can see it. So they are very different, and uh, and so the target market and everything is very very different. People, Unitree does not want to put in the effort to actually um, come up with the autonomy on their own. Their idea is get them out there, let the researchers build that for them, and build that ecosystem. That might be a clever strategy. Could be a very clever strategy. But time will tell. There are some people who may want something like that. Others who might say, "No, I want to have labor on demand. This robot as a service. Just come on over and have everything do it. I don't want to program it. I just want it to work."
Yeah, I saw the video from I think couple of groups about using Unitary, and I think it just blew up every time. It was just amazing, backflips and wall flips and
Oh
all
yeah,
those kind
yeah,
of
yeah,
things. I don't know if
yeah. It
it's
is. I mean, all that stuff is amazing. But again, it's distracting you from the fact that they cannot do useful work. And again, Michael Cho has said that the robots will be funny before they're useful. So that's why we're seeing them be used more in like these entertainment spectacles and sports and doing everything else because they're distracting us from the fact that they don't have functioning hands and they're not demonstrating actually doing anything useful. So if you look closely at the videos, not just from Figure, also from 1X, also from Tesla, definitely Agility, Digit, um, Boston Dynamics, Apollo, they're they're showing the bots doing something useful in factory settings. And you can imagine, okay, that's great. And they're designing it for it. Now, of those, Boston Dynamics is the only one that's sort of been able to figure out how to do. I don't know that we've seen Boston Dynamics do backflips, but they've been able to do somersaults and stuff like that. So it's kind of an impressive machine, a very expensive machine, unfortunately. But it's impressive and they're all right. But again, they're not trying to show the wrong capabilities. They're trying to show the right capabilities. And the right capabilities, keep on saying, the business end of the robot are the hands. And that's what you should be focusing on. So walking speed, we don't need it to be the Flash. It would be dangerous to be running around as fast as the Flash. So they need to have a normal walking speed, which is sufficient. It's not a turtle, but then again, maybe we should go back to Aesop's fable. You know, slow and steady wins the race. So the just moving along at 1.2 meters per second is far more useful than being able to do backflips all day.
But I think one of the question about the hands, what's different about the hand
Okay.
and compared to the competition? I think that's really important question because I think they mentioned softness in the hand besides tactile sensing, design.
Yes.
I think they described this in the white paper. So
Okay.
what are your impression about?
Okay.
Yeah.
Yes. So one of the things is that everyone is trying to come up with some form of tactile sensing, and you can buy some sensors out in the market, and most of the people that have looked at this have said that they don't have the capabilities that you want. So if you want to build your own, you can go ahead and do something like that. So they went and developed their own set of sensors on there, and now I wasn't sure when we did the hot tag. That's why I'm glad that we've waited like more than 24 hours. Might be longer than that, to get kind of the facts and everything correct. So the sensors are in the hand; they are not in the glove. The glove is only a covering, and the glove does have something that goes around the wrist that keeps it in place. So I was speculating that if there was some sort of sensors in the glove, that might be some way that you make like the contact for the data. It's like, nope. If you take the glove off and you still have the sensors in there. So the glove is to protect the hand, um, and to also make sure things do not get into the joints, because no one's been able to develop a hand joint yet that doesn't have openings and crevices where things are able to get in. So the gloves are specifically designed to be able to do that. And they do have some non-slip kind of capability on there to make it a little easier for tactile, but the tactile sensing is actually built in the fingers. It's still a 16-degree freedom hand. It does not have abduction, and it is not tendon driven.
And the bone camera. What do you think? There's some people division about why they use that. In the white paper also mention why, but what's your take about the bone camera?
Again, there's a lot of people that think it's unnecessary, and there's a lot of researchers that think it's a extreme benefit. It may be one of those things that eventually you don't need it, but you remember right now, we don't know how to solve this problem. And a lot of the problem right now is a data collection problem. And having the pond camera down there will be able to help you in a lot of the data collection situations to be able to speed that up. And eventually you may not need it, because it's not like they're put down there because they don't have tactile sensing. Clearly they have tactile sensing. But a lot of it is to make it a little bit easier to grab objects that are obscured from the system. So it's, but it's not like it's a crutch. It's obvious that when you go and grab something, it will be obscured. But they don't care about that. They care about in the process of grabbing something, we need to see it. And we're well aware that as soon as we grab it, we're probably not going to be seeing anything anymore. But that's not our primary camera. We also have these other cameras that occasionally it will be blocked. And we can see that it does have LEDs on it. So the palm camera is lit. And so that will help, in darkness to be able to see things. So that's part of the function. One of the criticisms is like, man, it's like that's going to be exposed to everything. So that they'll have to make sure that the lens and everything like that is designed such a way that it's scratch resistant, or like maybe easily replaced, or you have to clean it a lot. And I can come up with 1,000 reasons why it's a bad idea to have the camera down there, and I come up with 1,000 reasons why it's good. And so if I'm out, you know, digging in the yard and pulling up weeds, maybe having a camera down there's a bad idea, because it's just like it's going to get all dirty and you're never going to see anything. Okay. If that's my use case and my only use case, maybe it's a bad idea. But if it's like trying to find things in the cupboards and grabbing things, and it's not in a situation where it's going to constantly get dirtied, it's not working in a machine shop or anything like that, then it might be fine. So again, it's kind of these philosophical arguments everyone's having. I can understand why some will say it's not necessary. We think we have other ways of doing it tactily, and but there's a lot of researchers in universities that are putting them down there and gathering good data. Now, speaking of cameras, there are other cameras on the bot as well, um, that we can see in the image. So each palm has one. There's also on the face mask, We can see there's a lower one down here in the chin, and there's one up in the top here. And we can also see there's one in the back. There's one in the back. Yep. And there's one more.
Okay, where the rest?
Well, okay.
I can't. I
So
have to guess. I have to guess.
you have to guess. So we can see the one in the back that's there. So there's a camera in the back. The two in the front, we can see one at chin level and one kind of
Maybe one the chest?
up at the forehead. Nope, nothing in the chest.
Okay.
It's
Um,
still on the head, but it's one.
hmm. Still there, but it's one. Okay. Maybe the front eyes. I don't have that. No.
It's it's where no one would expect it.
Just a second. Don't say it. Okay. I can't see. Why I can't see? So it is in the head,
It's in the head.
as you can expect. Hmm. And the chin.
No, they already have a chin cam. There is one down the chin.
Okay.
There's one kind of up in the forehead, one in the back.
Mm-hmm.
So I want you to take a line from the chin to the forehead to
Okay.
the very back.
Uh huh.
And as you go
Yeah.
along there, I want you to stop
Ah, it's
halfway.
here. It's here.
You
Here.
you know
In the top.
it on the very top, yes.
Oh my god. Why is that?
Um, Seagulls.
But I didn't see it. Ah, but it's not clear in the
No,
video. Did you see?
it's basically, if the seagulls are gonna come down, land on his head, we'll see it ahead of time and be able to say, "Stay away."
Wow. Okay, but
So that's yeah, I call that the
okay,
seagull cam. I'm not quite sure why, but evidently, there's some benefit and, maybe it helps with navigation in some way that, to be able to see
interesting.
if you're looking up at the ceiling, that's like yet another way to give you a reference. So that was an
Hmm.
unexpected position.
Very interesting. But do you think the hand compared the like Wuji hand and overall there's big differences or just in the tactile
Oh, I
sensing
mean,
and the
they're all
camera?
differences. Again, I guess you could say almost like 3 approaches to the hands that we're seeing. Um, there's a lot of people that are and maybe there's 4 approaches. A lot of people just going with a tendon-only hand. Um, a lot of groups. So it's not like there's just one small group that thinks this is the way. There's a lot that are looking at it and are really convinced that, tendons will be the way to go. There are others that, that have looked at it and just said, "Gosh, they're just so finicky. We're having such problems. There's got to be an easier way to do it." And so the other way is to create these linkage mechanisms where you don't have any tendons involved. And in that case, the actuation is usually down on the palm. And so your actuation has to make it very thin. And this palm is much thinner than the previous hand. So there's definitely been improvements there. And I'm not surprised because actuators are getting smaller and more powerful. So it allows you to do that. And so you can get a lot of the dexterity that you need, and so it has all the IP joints that you need. It has the capability to close the fingers down and then curl up for grasping. The touch sensing that's built in there. It doesn't have, let's say, some of the issues that you typically have with tendons for stability. You can get decent grip strength and control. There's some ways it's easier to get control. Some people will argue that, well, we could probably get better grip strength with the tendons because we can get much more powerful actuators down here in the forearm that allow me a bigger grip strength. And again, that this is the arguments are going back and forth, like tendons versus palm-based actuators that are using linkages. And Figure's not the only one that's doing that. There's many other companies that are also taking that approach. Then there is the Wuji hand, which is kind of one of it's another attempt to try to build the actuators and right into the hand itself. So, and one way of doing it, which I think Unitree and others, is that they tried to make micro drives that were literally right at the joints. So their fingers are like teeny robots, where tiny, but the micro actuators were just too weak to really give you the kind of grasping strength you want. And Wuji kind of turned the script around to the wait a minute, let's make the phalanges actually the motors to do it that way. So that's like direct actuation. You could say that kind of strategy. So it's not like a linkage strategy. It's a very different one. The concern with that is that while you have very good precision and control, it's not clear that you're able to develop the grip strength with that. And it may not be as strong as the grip strength that you would get with a linkage mechanism. But time will tell on that. And then the probably the last strategy is this hybrid strategy that many are considering, and that is that when you go to a tendon base, especially when you want to have full control, your abductors are the ones that are really tricky to position to get the strength that you need to keep it in there. Because if any load goes on the wrong way, they're just kind of spread out. So it makes it very difficult when you do like a pinch or something like that, that it wants to move around. And the other thing is if you're using tendons, depending upon the kind of actuation, if you're using like a linear actuator to pull in the puppet string, well, you can only have one puppet string, which means you need one for the ab and the other for add. So suddenly your abduction is taking up nearly half the actuators you need for everything else. And it's like, man, that just seems like overkill. Would you want to do that? So many groups are saying, all right, abduction, we're going to actually have a direct linkage connected to just to something. So we can have the number of actuators that we need. We don't have to double it up, and we can have much better position control, and we can lock it down. But for the flexion, we're going to go ahead and use tendons for that. And so that's like another design approach that I was using. It's not for me to say which is the best or the worst. A lot of cases, it's going to come down to reliability, durability, and capability that they're going to have. The tendon-based hands, at least in principle, many people think will have superior capability as far as dexterity and what they're able to do. Whereas they question some of these other simpler approaches, but these other simpler approaches are much faster get to market strategy that will allow you to do it and may be not only cheaper to build, but maybe far more durable and have more than enough resilience and capability that what you want right now. So it's sort of funny. I hear some people will say perfect is the enemy of good enough, and other people say good enough is the enemy of perfect. And and so it's like the perfectionists that can't get the product out the door because they have such super high standards, and others that say, you know what, these super high standards are preventing us from get the product out the door when a lot of people will be more than satisfied with good enough. So that I think is sort of the tension that's going on, and it's a design approach. It's a company philosophy as well. A lot of times people think we're so close, we're that close to getting the perfect. Let's go for it. We don't want to wait for the next one. And sometimes it turns out it's a little bit harder to get that last 10% that everyone's looking for. So these hands are more than capable enough. We've seen other robots with less capable hands already being deployed out there and doing useful work. And they can't do everything. I've seen hand designers obsess about all sorts of silly little things that are like, okay, that's all very nice, but what's the use case? How frequent is that use case? And is that something you really need to have? So, with hands and needing to have the abduction to twist your fingers around, if you want to put a screw something in, it's nice to have that capability, to put it in, twist it around. But there are other ways to do it, and that is like you have a tool with a screwdriver that you just place it down there, let it do it. So, so sometimes whether they may be overthinking it because if you are trying to make these general purpose, but you're putting them on a factory floor where you're putting these things in, that's inefficient even for people. I'm not gonna have someone on the line doing this operation that like is very difficult for them to do. I'm gonna figure out how do we come up with a simple piece of tooling that's easy for them to get it in there, that they don't have to do that in the first place. So a lot of times they may be trying to solve a problem that isn't really a problem.
I like this, and I think one of the question I or maybe the remarks I see yesterday in X, some people say that I think they were shedding light on Dyna Robotics. I think you already saw what they do in the folding closes. So I think
Yes.
what's happening now is just killing all this use cases that, yeah, basically folding closes where you have to have this specific two arm robots doing the task, like physical intelligence. You know what I mean? So
Yes. Yes.
do you believe that's the case?
Those
Because
are
just
those.
now figures showing that
Yes.
possible or impossible.
See, this is the difference of that. First, robotic folding. is really impressive. It's something that researchers were trying to solve back in the 80s, and they realized, my goodness, this is hard. So what's ironic is that back in the 1800s, we were able to come up with machines to sew, right? So sewing machines, and Singer sewing machines, stuff like that, and that's like one of the most difficult things about making clothing is sewing. And so you think, now that they had that solved, then we should be able to come up with these machines that can just make a full garment. But no, we still have people having to feed the garment into the sewing machines. And people back in the 80s trying to come up with robots, they thought, oh, we could just take these robots and move around there. And it was just so hard. So even though robots are considered a part of what's called flexible automation, that's one thing they can't do. They can't deal with anything that's flexible. I prefer everything to be rigid and hard. And it's been a hard problem to deal with fabric. And folding is like one of those. And then I think we're beginning to hear that there's some other researchers that said, yeah, they finally get it that they can start actually making garment all the way, because textiles, you'll notice, is still a very manual process, despite the fact we're able to automate the stitching. But the feeding of it is been very hard, and that's the same thing with folding. So when it comes to a folding robot, a specialized folding robot, it's it's not general use case enough, because it's only useful in situations where your job is to fold all day. And there's very few places in the world where things need to be folded all day. Now, it sort of varies. A lot of times you will have, like, restaurants and hotels that outsource a lot of their towels and napkins and stuff like that to some company that does it. And so that company might just be doing it all day. They're washing these things, they're folding these things, and then they're delivering to the restaurants. Others, it may be, well, the napkins come clean, but we have to fold it. Now our wait staff is going to fold that. That's part of the prep process and usually they're done in half an hour, and then the staff goes and does something else. So it's not like there's someone whose job is like the whole day long to fold all the napkins that we're going to need at the restaurant or the hotel. It's one of these things that's just a couple of hours. So who's going to want to invest in automation that is going to be idle 23 hours? If that's all it can do, and it can't do the rest. So we've seen examples of, proposal of a lamp that will fold the T-shirts on
Yeah,
bed.
I saw that.
I mean,
Yeah, what do you think of it?
well, I mean, it was a cool idea. The problem about that is there's all these things it can't do. Is you notice a human had to unload from the dryer and bring it in the first place and throw it on the bed. And then when the folding was all done, the human had to then take it in and put it away. All right. So, again, what it means is it's only able to do a small part of it. Now, a lot of people might say, that's fine with me. It's the same reason I buy the Roomba, is that, yeah, I still have to do a lot of the vacuuming, but the Roomba takes care of the 80%, or it runs every day, so I don't actually have to vacuum as often because it just gets the little bit of things. And yeah, the Roomba's slow, but you know what? It does it when I'm away, so I don't care. I come home to my house being vacuumed. So you may be happy with something like that. So a lot of people, I say, you know what? It takes me 30 seconds to unload the dryer and then just throw it on the bed. But then it takes me a long time to fold all that stuff. And then when I come back, it takes me another 30 seconds to go ahead and put them away. So it may be that you see utility in that, but unfortunately, what that means is that bot, when it's done, isn't doing any much. Now, he was very clever. It said, we're going to turn that into a lamp. So it does two things, because the problem with a lot of robots, like my Roomba, when it's done, it's going to nest itself somewhere. So it's going to hide somewhere. So either it's hiding in a closet, which means it's taking up space in the closet that I can't put boots or something like that, or it's out in the living room, which means it's kind of, it's going to be seen. So the same thing with like a folding bot or anything else, like an ironing table, you got to take it out and then you got to put it away. So I've got a folding bot. Do I have to take it out and then put it away? That's a hassle. But if it somehow blends in my furniture and then turns out to be a light at the same time, maybe that's not a bad idea of this idea of getting a 2-for-1. We'll see how popular that is. But the thing is, if you get something that is a very expensive piece of equipment and its utility is limited to, like, it's only 10% utilization, 90% downtime. It's not very useful, and I could be spending lots of money on all these little special robots, specialized bots, and the sum total of all those might be way greater than buying a humanoid that can do them all, even if the humanoid can't do it as well or as fast, or maybe it does it as well, but it's a little bit slower. However, the humanoid will do the first mile and end mile of the problem. It will get the stuff out of the dryer. It will bring it in, and it will sort it correctly because it knows whose clothing is who. So it makes the piles correctly and then moves those piles to the correct dressers. So see, this is why a lot of people, the arguments you'll see in there, like humanoid is a stupid idea, or a specialist robot will always do that better. And I absolutely agree. If you are a laundromat and you just need to fold towels at a really rapid rate all day long, you want a specialized piece of equipment for it. But if my home is not a laundromat, yes, I have a laundry in there, but I'm not using it 24/7. I'm using it a few hours during the week to get a couple of loads done, and a specialist robot makes absolutely no sense. Yeah, I want a general purpose robot, and this is why the the idea of specialty versus generality. It depends upon the volume, and if your bot is not getting 95% utilization, then there's something wrong. You're applying it wrong, or whatever automation you have. That is capital that is not being well spent. And again, I saw a t-shirt folding machine. I mean, you can just Google this. I said, okay, everyone keeps on saying, why not just a machine for it? And I said, well, some people have done it. I looked at it and I was just laughing because people had to feed the machine to begin with. And not only that, they had to be very careful how they folded loaded the machine. And they literally were like pre-folding the stuff going into the machine. You could just dump it in this supposed folding machine. Now, in this case, it's a little bit different because obviously it's just being dumped and it's figuring it out.
As you say, it depends on everyone. I think as you say, that it depends on its factory or home or whatever or
Yes.
hotel. I
Yes.
think the cost, how much you're willing to pay for that, and I think that it comes down to all of these options. In the end
How
of the
much
day,
space is going to take up? Yeah.
yeah.
Yeah. Whew, you know, kitchen countertops are just littered with all these silly appliances. We have sit there that we rarely use. There's no space left on my countertop to do anything because we've got to have a special blender for this, and there's something else for Big Eel to make smoothies, and like three different types of toasters. Oh, we need something for doing bagels. You know, we need something for doing normal toast. We need a toaster oven. Oh, we need a micro. It just all these specialty items that are great, they become expensive after a while, and they take up room. So I think take that approach to your home is to imagine all those things and every one of them being like, you have one more appliance that you have to buy. The best thing is to not have something that's able to do the tenting and so many other things. The form factor allows it to get into your rotted bedroom. The wheel vehicle may have a hard time navigating. But I mentioned this before that if you look at a wheelchair accessible home, it's very different than a normal home as far as the doorways have to be a lot wider. Everything has to be flat. Make sure there's no bumps. Your furniture has to be arranged in a way it's not too close to the wall. All these special things that you have to do. And that's what would make a wheeled bot very difficult, let alone being able to go up and down stairs. Especially, the one part of my house got spiral staircase. And it's like, oh, okay, you may think you have some clever device to pick up and down, but that is like even another trick of being able to go up there that a bipedal bot has absolutely no problem going up something like that. So, um, wheeled vehicles will have their use cases, and I think their use cases will be in places that are intentionally designed for wheels. So, like hospital, you go to any hospital, a hospital is designed for things on wheels because moving things on wheels so they're all the time, not just people in wheelchairs, but gurneys and everything else. Every single room has to be easy to get in there, no bumps, nothing I have to jump over. Big elevators to make sure we can change levels and stuff like that. And that's why there's already mobile robots in hospitals for decades that automatically go up around that, take test results down to the lab and bring it back up and just do all the stuff that orderlies used to have to do of running these things around. And they function very, very well because that space is designed for it. And there may be some factories that are laid out perfectly well for that, but others that are not. And calculations that have been made is that if we want to make all our factories go dark, oh, and we're gonna do it with wheeled vehicles, the amount of re-engineering we'd have to do would be ridiculous. The idea of the humanoid is a one-to-one swap out of what we know already works. The human form factors working in those factories right now. So if we wanna automate without changing everything, and we changed everything in the '80s and '90s to accommodate the industrial robots, and it took a long time to do that.
I think also one of the question, I know I took a lot of time for you, but one of the questions, when do we go and sell it in the market? Like we see this iteration, and I think this is the again frustration. But I understand the safety. I understand 100%. They take things maybe carefully. I think that's the case. But do you have an idea when they can start to sell it, and who will be the first? Maybe they showed it in with BMW. I think the video that they have been
Yeah,
operating
yeah.
this nonstop.
Okay, so, and there was also, like, some recent announcements, with Brookfield. So I think they're still in a major data collection. So, uh, next year, everyone's gonna be ramping up. I expect that, Figure probably could have a couple 100 F3s built, if not already built, because we know they've built 100 battery packs. Maybe, they'll have a little bit more. I don't know if that's the bottleneck in the production. Maybe there's something else that maybe they may not have automated everything in Bot Q. So it's like they probably have tons of helmets and faces, face plates because they already showed that operation. Um, so I don't know how much the actuator line or anything like that has been spooled up. They so that but right now, the capacity is for being able to do 12,000 bots a year. So there's a good chance they'll probably be close to that next year, or at least the run rate by the end of next year will be there. So whether they've actually made it to 12,000, so I expect high thousands next year. And then after that, clearly that they're at that, and then probably able to scale very quickly after it, because it may be just a matter of like running double shifts or something like that, to get higher numbers. So with the hope of 100,000 within 4 years. So that's the guides that we sort of been getting, and it looks reasonable. 1X is also sort of announced as well. Excuse me, there's a motorcycle going by. All right. So 1X has also said that I think this year or early next year they plan on selling them, or I don't know if it's selling them or getting them
Is it
deployed.
1 million true? I
Yeah,
saw
yeah.
the Speedy. 1 million.
Hmm?
I saw Speedy.
Oh,
The influencer.
it's not,
It
ignore all of that. Oh, it's not $1 million.
okay.
No, that I think was just clickbait on that title. I think I think the bot is significant. I don't think it's anywhere near that. So they already have an early adopter program that I think early next year, they'll be going in for data collection, and everyone is being careful. Barrett publicly has been talked about this. Brett yesterday, also in his time interview of saying that, there's kind of a cautious rollout. And everyone has to understand that these bots are not going to be fully capable early. And if you're open and transparent about that, then people won't be disappointed and the bot can't do everything you want it to do right now. But the understanding that what you're doing is getting it to that point as an early adopter, that will be able to do it. So you're going to have to be patient with these things and to help with the learning. So these large numbers next year, and no, I don't think anyone's going to be selling. Say this is the frustration. Yes, Unit 3 is going to be selling. I don't think any of the North American companies are going to be selling. They're only going to be leasing them, or doing it, basically as robot as a service.
And why that Scott? I think maybe I understand energy tech is shortcut, but do you have an idea why? Because people say why this. we can't do
Part
what the
part
teenagers.
of it is that, um, there's so many people who would wanna buy them right now, they would have no problem selling them if they made them. You say, "Okay, you can come and buy them." But the idea is not to make a quick buck. The idea is to grab the brass ring, and in order to do that, you need, the data. You need to make sure the bots are fully capable, and that is just kind of getting them out there and people starting to use them. There are a lot of people, yes, individuals that be willing to spend a lot of money to do that, but more more to the point, really, businesses that would see the value of $100,000 per year for one of these bonds. Maybe even more, but everyone I've talked to, it's like right around $100,000. The thing is, there'll probably be some other company willing to pay 150 or 200, depending upon the use case. And in many cases, what has to be done might be simple enough that the bots are capable enough to do it now and can do it, and they would pay that. And so long as there's a demand like that, you're not going to see the price go down. So I don't know that they're not telling us what the sale price is because they won't be selling it. And they've already, entered in agreements with a couple of companies. We don't know exactly what the arrangements are and how much they're paying. But yeah, the expectation is that these pots will be somewhere around $100,000 a year as a service.
And how you have an idea how durable it would be? Like how many years you can,
Oh, I
or
think,
it's just early?
yeah, I think for most of them, if done right, you'll probably be able to get 3 to 5 from them. But the thing is, if you're doing it as robot as a service, you don't care how long the bot lasts.
Yeah.
When you buy it, boy, I care. But if it's robot as a service, it's on them that if the robot breaks, they replace it. If the new generation comes out, then they bring the new generation in because it'll probably be cheaper for them to operate the new generation than they keep the old generation going. And then maybe they find some place for the old generation where it's still useful. But most of these with proper service, and there will be preventive maintenance that has to happen. That will probably be, maybe some daily, certainly weekly for sure, a little bit of monthly, and probably like a yearly one, which will be a much bigger kind of overall inspection and all these. But I think it would be very small compared to what's actually being charged, whatever the biggest. That will probably be part of the maintenance, and it may depend of the use case as well. Is if it's being used in a use case that's really dirty and there's like a lot of cleaning, uh, then you might say, well, we're going to charge a little bit more because you're kind of abusing the bot versus one where it might be used more lightly or at least not in such an aggressive manner. So you could see things like that. Too early to know numbers, but every company that I've spoken with recently, they're all kind of aiming to be around 10,000 bots next year. I mean, that's their internal numbers, and they all pretty much believe that they could hit that. Everyone, it's kind of interesting that they're all about the same. Yeah, and China for sure. There may have been some that already have hit that and may have higher numbers next year. We'll see. Yeah, I wouldn't be surprised. You'll hear some company that will be high tens of thousands. Maybe even try to do 100,000. But the bots will be of a completely different kind of scale or than these.
Well, I leave this last space. I think the city bark. You shared this with me, so I think I'm not sure. I did have the time to look for detail, but I think it was interesting. I think he said that every Thursday he's looking for this patent. So I think that was really cool
Yes.
that he found it.
Yes, yes, yes. So, Seti Park has found quite a few patents, which I think are rather interesting. I think it was in August a patent that figure actually applied for a few years ago became public. So that's usually what it is. There's like a filing date, and then it just goes through the system, and then suddenly shows up. And in August, it was more or less a patent for Figure Two, and like a full blown description of Figure Two, which is like, well, we've already seen Figure Two, and if you look at it, it's almost like they're asking for the patent on a humanoid. It's like, oh my gosh, they actually have the patent on the humanoid. It's like, no, no, no. It's like, it's not clear that you could patent that, or if anyone has. In many cases, these are more of defensive patents, and that they're sort of defending their right that they own the intellectual property right to this sort of arrangement of everything. And it's a really long patent. It's like 100 pages. It's just dry, the driest reading you will ever had in your life. And it's somewhere where they say words like, it twists about the twist axis by twisting, and you're like, what? Wait a minute. It's like self-referential kind of language. It's hilarious. Uh, and, but it, it- but it wasn't, yeah, but it wasn't aware of that in many cases, patents are used more almost like trademark more than patent because it prevents people from coming up with an appearance of the body that looks exactly like yours. So it's a way of more or less protecting your brand as opposed to protecting more of anything else. So it is kind of defensive in nature, but it's not really something that gives us keen new insights in there. And it does not mean they own the rights to a particular hip arrangement or shoulder arrangement or anything like that. Because we all see they're all using the same kind of thing. It's more or less like, hey, if you come up with a robot that looks just like a unitree, you know, you can't do that. Make enough changes to it. It can be kinematically the same as a unitree, but if you just make enough design changes to it, then it looks like yours. That's it. So, but evidently, I don't think it's something you necessarily copyright. And evidently, clothing. I was kind of surprised to also hear that a lot of times clothing is patented the same way.
Oh, wow.
Yes.
Really?
Yeah, to protect a certain style or way of having something. Yes.
Well, that was interesting, and I appreciate, you taking the time to do that, and I think, yeah, it's a very exciting time, and I wish you safe travel back, and, we continue hopefully in the discussion, so,
Okay.
okay. Okay, anything else for now you want to say?
That'll,
We said that.
that'll, yep.
Okay.
Bye now.